Problem number 3 of 10 for me. My skill's good. Let's see. Nadia is throwing a ball to Peter. Peter does not catch the ball and it hits the ground. The graph shows the path the ball it flies through the air. The equation describes the path is y equals 4 plus 2x minus 0.16x squared, where y is the height of the ball, x represents the horizontal distance for Nadia. Both distances are measured in feet. ABC, how far did Nadia does she throw the ball? How far from Nadia does the ball hit the ground? At what distance, x, from Nadia does the ball attain its maximum height? What is the maximum height? Okay, everybody have these questions? Okay, let's open up our calculator and do the new graph. So on, home, new document. I don't want to say this. And I want a new graph. Okay, our graph is 4, that's the initial height, plus, if you know, remember from physics, or if you don't know, plus 2x, that's the initial velocity is 2 feet per second, and then minus 0.16x squared. Okay, and here it is. Now I just need to zoom out. I'm moving this over a little bit so I can see. And the questions were, where is Nadia? Is my first question to you. Nadia's right here at time 0. So I can trace this. And that looks to be the maximum right there. I could put 6.66 in. So I think that looks like the maximum, not sure. 6.6 seconds later at 10.23 feet, that's the answer for that. I can double check by finding the maximum, if you remember how to do that. Analyze, max, to the left and to the right, and sure enough, actually it's 6.25 seconds and 10.25. Now I also need to trace and trace the graph. Type a 0, press enter, and that's that. Now, the other thing I want to know is the other 0. I mean the second 0. So I need to trace and actually analyze, and I want to find the 0. But the 0 over here, because I need to know how long before it hits the ground. So we have 3 points. This first point over here, where she's 4 feet off the ground, that's where Nadia threw the ball. It goes up to 10.25 feet and reaches back to the ground 14.25 seconds later. So then you answer that this way. So let's find that. The ball hits the ground 14.25 feet away. Is that what I saw? Yep. And okay. So is x and y both feet? Is that what they said? The path of the ball, where y is the height, and x is the horizontal distance from Nadia. So yeah, they're both feet. So 14.2 feet away, maximum height at 6.25 feet. Maximum height is just over 10 feet, like that. So next. Determine the correct answer to the following questions. Equations with the second part are called, what's x times x? But a square, or a quadratic. The name of the points on the parabola y equals 0 is? When y is equal to 0, is that the x-intercept or the y-intercept? If y is 0, that means this y is 0. Which axis am I crossing here? Which is this axis right here? This is the x-axis. Y is 0. That means you got the x, which is the x-intercept. So that's an x-intercept. This is just basic vocabulary, yeah? The point halfway between the x-intercepts is called the axis of symmetry. Okay. Oh, thank you. The point halfway between the two x-intercepts is called the vertical intercept, symmetrical point. I guess I would call it symmetrical point. I'll say that next time. Or it's also, well, it could be the vertex. Let me see. Let's take a look at the graph again. They're talking about the point between here and here. This point here is 6.25. That's the x part of the vertex. Okay, so determine the correct answer to the following question. A vertical parabola's vertex is the, well, what do they mean by vertical? Like this? It's either a minimum or a maximum. Maximum or minimum point of the graph. Okay. Vertical means that it looks like either concave up or concave down, like this one. Okay. Let's take a look at the next question. Determine the correct answer for the following step. Parabolas can be what? Can parabolas be linear? No. Symmetrical? Yes. Asymmetrical? No. Symmetrical would be the answer. These are too easy. That's why I wanted to do two lessons. The point halfway between the x-intercepts. Okay, people, give me an answer. Is it the vertex or symmetrical point?
Symmetrical point.
I have this bad feeling about this. That's what I thought. I've never heard such a thing, symmetrical point. Doesn't make any sense. And that's okay. Symmetrical point means, I think in my mind, would be one off the middle. The vertex is one of the symmetrical points, but it's the one on the mirror. So I'm going to say vertex next time. The vertex of the equation, such and such, is a minimum or a maximum. How can I tell if it's min or max, people? What,
Because it has a negative.
that means it's going to be concave down, which means it's going to be a max. Right.
Is
So.
this what we're supposed to be doing, Bob? Mister?
Okay, is the vertex of the equation a min or a max on this one? The 4 is?
It's a min.
Yeah,
It's a positive.
exactly. Too easy. Okay, I'm going to stop for now. Okay, you guys can... oh yeah, let me take my screenshot for myself. Oh, thank you. That's an easy...
Is that 5.8?
That's just 6.3. Okay, so I want you to insert a calculator page. Okay, recording the session, folks. And what I want you to do is we're going to type in x minus 3 and x plus 4, right? And let's store that. Store that. Control store into F1 or F2 of x, and it's done. So what that does is it stores it in the graphing page. But now we're going to solve this. We're going to put this in standard form. So this would be x squared, right? What's 4 minus 3? That's 1x, so plus x. And then what's 3 times 4? Negative.
Negative 12.
Right. So that I can store. Let's see if I can store it. Store it into F3 of x. And now, the next thing I'm going to do is I'm going to ask you these questions. So here's your quiz. Okay, let's work one problem out. X squared plus x minus 12 equals f of 3 of x. We can identify a, b, and c as 1 stored into a, 1 stored into b, negative 12 stored into c. The easiest answer you can see when you substitute a 0 is that you get negative 12. So we can write in a note that the y-intercept of the function is negative 12. Now the x-intercepts, you use the quadratic formula or the polynomial tool solver, and the vertex, we use this idea here. And I forgot to put a. And this is in parentheses. Got to make sure that we divide by the whole thing. Okay, so going back here, that's obviously, and I can do negative b divided by 2a. And that negative 49, whoops, have 49. I said negative 49 point divided by 4. In decimal is negative 2.25. So that's my y value, my vertex. And, well, actually it's not because I didn't type it right. Negative 49 divided by 4, period, enter. Negative 12.25 is my vertex in this case. And what's my y? Well, I have to figure out what negative b, oops, negative b divided by parentheses 2a. Of course, a is 1, so I just divide by 2. Negative 1/2. So if you look at the graph of this, you can verify that indeed, for this one, right, we can see, turning this off and moving this over, I see that obviously the zeros are at 1, 2, 3, 4, negative 4 and 3, and that this minimum point is indeed what I figured out it would be. Like I calculated over here. Right? Now, if you write negative, oops, negative b, excuse me, parentheses, negative b plus square root b squared minus 4ac divided by 2a, in this case 2, but just to make sure. Okay. They want me to put this somewhere. I didn't like the fact that I didn't put it times. These have to be in boldface, so it's you're accessing the variables that you defined earlier. So that's 3. And if I change the sign to a negative, that's the other. So that's if I had to do it by hand. That's how I would do it, something like that. Okay. There you go. So what are the zeros? 3 and negative 4. And 4. Right? Wait a minute. Did I copy this wrong? Looks like I copied it wrong. It's got to be negative 4. So this has to be plus. And when you guys were factoring stuff, so this vertex came out to be, well, so negative 1 divided by 2, f of negative 1 divided by 2 turns out to be negative 1 divided by 2, negative 12.25. Okay, and that's it. Okay, one more thing. We have factored form, standard form, and of course, we could also have gotten the vertex also f3 in completing the square. You would write x squared plus, see that x we have to split that in two. So that would be half x plus half x, close the leave a space, close the parentheses, leave a space, and the minus 12. Then what's a half times a half? What's 1/2 times 1/2? 1/4. Because 1 times 1 is 1 and 2 times 2 is 4. But you must also subtract the quarter. That's adding a 0. So that minus quarter, I'm going to cut it out of here. Oops. And move it outside the parentheses, like so. And then decide what this is. So that then becomes equal to, copy this, up to here, put it in here, and then get rid of the square here, and square it, and then add these two pieces together here. Which is negative 12 1/4. Or like this. And this is the, so this right here is the vertex. And so this is transform formed. The transform form is also called the vertex form when you're dealing with quadratics.